Hey there, educator. Welcome to the show. I'm your host, Lanisha, and I'm all about helping educators make meaningful connections in math instruction. If you've ever attended one of my live professional development sessions, then you know how truly passionate I am about this teacher life. PD for the Soul is my space for providing professional development on the go, where you can take what you need and place the rest on the shelf for another day. New episodes drop every Sunday at 9 a.m. Eastern Standard Time. This is where we will dive into strategies, routines, and insights to help students build deeper understanding. And here's something new. Our monthly newsletter launches on March 1st. This will be your go-to spot for links to all resources we discuss on the podcast. I want you to have everything in one place. Plus, I'll share the books that will shape upcoming solo episodes in case you want to read along. But that's not all. The newsletter will also explore connections across domains and grade levels, because when we keep those connections at the core of our instruction, we give students the tools to make generalizations that make new concepts more accessible. So, hit subscribe, stay connected, and let's make math happen. See you in the episode. Hey there, educator. Welcome back to PD for the Soul. I'm glad you're here with me today because today's conversation is one that is close to my heart. And I know I always say that. That's because everything about education is close to my heart. But seriously, today I really want us to take a moment to step back, not to pause, but to really reflect on the weight of what we do. As educators, we hold a tremendous amount of power. Students are in our classrooms for 10 months out of the year, and during that time, we hope we're doing good. 1 year might not seem like much compared to a lifetime, but when you consider that primary and secondary educators are basically members of the foundation laying committee for our students, it starts to look a little different, okay? When you look at it from that perspective, that year holds a lot more weight. I remember my first year teaching like it was yesterday. I wanted to do good. I really did. I got to work early. I stayed late. I planned. And I also made a ton of mistakes. I was brand new. I had no clue what it really meant to teach. And I think, honestly, teaching often gets minimized. Like, it's just something anybody can do. Now, don't get me wrong. I do believe most people can learn to be great teachers. I don't think everyone is just naturally a great one, though. A lot of us, we do what feels right until it doesn't feel right anymore. Or until someone we trust pulls us aside and says, hey, this thing you're doing, it's not quite working the way you think it is. I came across an article and something that I read really stuck out to me. Okay, it's called The Long-Term Effects of Ineffective Teachers, written by Alex Friedman. The major takeaway here was students who are placed with highly effective teachers for 3 years in a row significantly outperform their peers. Just 1 year with an excellent teacher can keep a student ahead for years. But guess what? The opposite can also be true. One ineffective teacher, it may take 3 years for them to catch up to their peers. And if they get stuck with 3 ineffective teachers in a row, most of them never catch up. I also read this Q&A with Eric Hanushek from Students First, and he laid it out plain. A strong teacher can help a student grow a year and a half in a single year. A weak teacher, only about half a year. Stack a few of these years together, you're not talking about learning laws. You're talking about a student's entire life being altered. Let's break this down and let's make it real. Imagine we have 2 students starting 4th grade, same starting line. Both of them are on grade level. Student A ends up in teacher A's class, who is a highly effective teacher. Student B ends up in teacher B's class, who is ineffective. By the end of the year, student A has grown a year and a half. Student B has grown half a year. If that pattern continues, by the time they get 8th grade, student A is 4 grade levels ahead of student B. And again, that was assuming that they started on the same level. We know that's not always the case. One of them, in reality, in our classrooms today, one of them might be on grade level, the other one might be already 2 years behind. So if we're talking about them going into ineffective teachers' classrooms, those gaps get worse. Now, I'm not sharing this to stress you out. I promise you that is not my goal here. What I do want to do is impress upon you that our role isn't just important, it's critical. We have power. And we have to use it intentionally. And I get it. Most of us can't avoid doing some damage in that first year. We just don't know what we don't know yet. But that's where professional learning communities come in. That's where quality professional development comes in. That's how we start to minimize the damage and maximize our impact. Over the last few solo episodes, I've been talking about what a lot of folks consider minor details. But honestly, I think those minor details are where we're losing the most ground. Let me give you a little analogy. Imagine you're driving through a construction zone. You run over a nail, but you don't notice it right away. Everything feels fine. Car hasn't changed the way it's driving or anything. A few days go by and you realize your tire's low, maybe your light's on, but you figure maybe it's the weather. No big deal. But then boom, one day your tire is flat. That nail has been slowly letting the air out, and all it took was one bump in the road for everything to fall apart. That actually happened to me once. I didn't even realize the nail was there until it wasn't, until it came out and left my tire totally deflated. Luckily, I was somewhere safe and there was a tire shop right next door. Now think about our students. What if they've got a nail in their tire? Some concept they were taught incorrectly. They move from unit to unit, grade to grade, not realizing their understanding is slowly leaking. And then bam, they hit a bump. Maybe it's a tougher concept or a new teacher with different expectations, and suddenly everything deflates. If they're lucky, they hit that wall in the care of a highly effective teacher who can help patch it up and rebuild understanding. But if they land in Teacher B's classroom, then what? If you've been with me over the last few weeks, you know I've been talking about the importance of correct and consistent language, staying away from meaningless mnemonic devices, using precise notation, and presenting cohesive, consistent representations. If you've missed those episodes, please go back and check them out, because today we're building on all of that. We're talking about rules that expire. The Math Pack, the book that we've been grounding our conversation in, define these rules that expire as deeply rooted traditions in math education, shortcuts or strategies that seem to help in the moment, but don't hold up over time. They're taught because they make things feel easier or more memorable. But easy today doesn't always mean effective tomorrow. Just like with my tire, I don't know how long I was driving around with that nail. It exploded before I even realized there was a problem. So let's get into some of these rules, because I don't want your student, my child, your child, I don't want anybody's child to experience an explosion. So first up, does multiplication always make numbers bigger? Well, Terrence Howard seems to think so. I can't even count how many times that video has been sent to me, and every time I cringe, because the truth is, no. Multiplication doesn't always make numbers bigger, and division doesn't always make numbers smaller. But those ideas, they're common. Teachers say them because they want students to grasp something quickly. And sometimes there's this unspoken assumption that the next teacher will fix it later. Other times, the teacher just doesn't know that the patterns they're seeing in their grade level don't hold up beyond it. That right there, that's why we need consistent vertical conversations. If this rule breaks down with multiplication and division, you know it does with addition and subtraction too. When students first encounter negative numbers, mind blown, especially when they realize they can subtract and end up with a bigger number. Let's talk about another one. Do you have keyword posters hanging in your classroom? Be honest. I bet you do. I probably did too. And look, I get the appeal, but this next one's been holding on tight. Use keywords to solve problems. Now, I do believe students need to understand words. Obviously, I did a whole episode on the fact that words matter, and apply them in context. But we shouldn't be teaching them to grab onto words and automatically associate them with an operation. Let's take probability, for example. So often we teach students to focus on whether a situation is an and or an or problem. I used to do that. I'd have students label problems and match the words to the operation. We're either multiplying or we're adding, y'all. That's what we're doing. Let's go. But when I started digging deeper into the numbers, into the concept, my mind changed. So I want to take you through an example that I've really been talking about this month, since it's Math and Statistics Awareness Month. You can check that out on TikTok. But yeah, I want to walk you through an example. Let's say you have a bag of marbles, various colors. The problem says find the probability of selecting a red or yellow marble. Let's not even worry about how many marbles are in the bag right now. Let's not worry about what the colors of the marbles are. I just want us to think about for a moment what things should be coming to mind. Okay? So one thing that should be coming to mind is the part-whole relationship. So the number of red marbles, the number of yellow marbles, and then the number of total marbles that are in the bag. That's one thing that could be coming to mind. Another thing is I could represent this using fraction notation. Another thing that should be coming to mind is that the values to represent this probability are going to fall between 0 and 1. If there are no red or yellow marbles in the bag, the probability of pulling a red or yellow marble is 0% chance. If every marble is red or yellow, we have 100% chance of selecting a red or yellow marble, or the probability will be 1. I want you to think about that as if I tell you to pull a red or yellow marble, I want you to think about that as casting a net. And in this situation, your net is wide, right? I have restricted it to only 2 colors, but either one of those colors will work. I ain't picky. Either one of those colors would work. So I've casted a wide net. Now on the flip side, let's say that I ask you to find the probability of selecting a red marble first, then a yellow marble second. That's a lot more restrictive. It's a narrower net. So we should expect a lower probability. If we laid those 2 scenarios on a number line between 0 and 1, right, the red or yellow case would be closer to 1 than the red then yellow case. And we didn't even mention operations yet. When we push students to rely on keywords, we push them away from reasoning, from sense making. Context always matters more than isolated words. This whole think aloud that we just did just now, we didn't talk about any numbers yet. We talked about what should be coming to mind, what should come to mind for us, the things that we should be thinking about. And once I am clear on that, then I can talk about the operations and what operations make sense. Because if I know that the probability of selecting a red or yellow marble is going to be closer to 1, and both of those consist of fractions, right? What operation is going to give me a higher probability? Addition is going to give me a higher probability if I'm talking about 2 fractions that fall in between 0 and 1. If I'm talking about I need you to pick red and then I need you to pick yellow, those restrictions, what are the chances of that happening? When I cast a smaller net or a more narrow net, the chances of me catching something are now smaller. So what operation would allow me, if again, I'm dealing with proper fractions, for me to have a smaller number? Multiplication. When I multiply proper fractions, the value is smaller. Now, this is not the same as saying anytime you multiply numbers, it's getting bigger. No, because we're talking specifically about the type of numbers that we're multiplying and what happens, because we understand that there's a pattern that exists there after having explored. Okay? 2 totally different things. So, all right, I went on a tangent. Let's pull it back. Here are a few more rules that expire that I really want you guys to think about. I want you to reflect on. I know this is the end of the school year, so there's not a lot that we can change at this point, but we can reflect on the things that we've said this year, and we can start to make plans for what should take place next year. So 1, saying absolute value is just the number. So instead of doing that, instead of saying it's just the number, ignore the sign, let's teach them what absolute value actually means, right? We're talking about that distance from 0. That magnitude. Let's teach the students that. Always divide the large number by the small number. No. That depends on the context, who's doing what, and what are we finding. So let's focus on understanding the concept. A lot of times people talk about, the students aren't reading, the students aren't taking their time, the students are rushing, the students are just pulling out numbers and performing operations. Well, teacher friend, some of us have kind of set them up to do those things. We're not slowing them down and making them reason about things. We're just telling them, okay, when you see this, do this. Okay, if this number is big, that number is going in the house. Okay, so we've taken out the reasoning, the sense making, and then we're complaining about the fact that the reasoning and the sense making is not present. We got to make it make sense, y'all. Number 3, using PEMDAS. Okay, I grew up on PEMDAS, but the reality is PEMDAS, the way that it's written, can create the idea that multiplication always comes before division and addition always comes before subtraction. That's not true, right? So GEMA is something that the book suggests, and I actually like it. I mean, I'm not the final say in all of this, but I like it. GEMA stands for grouping symbols, exponents, multiplicative reasoning or relationships, and additive reasoning and relationships. Keep, change, flip is number 4. I hate it. Because kids don't know what to keep, change, or to flip, okay? Instead of saying keep, change, flip, let's link it to whole number division or reasoning through how many of these are in that. Common denominators is a great place to start in 6th grade because students are already working with common denominators with adding and subtracting fractions. So guess what? Now we have a more natural transition because you already know how to do this. So instead of me teaching you another new thing, I'm going to use a thing you already know. Next, the butterfly method. Enough said. I hate it. Yikes. Kids don't know when to use it. I don't know what it is. A lot of people don't know what it is. The kids don't know what it is, even though they've been taught what it is. So yeah, nix that. Improper fractions must be written as mixed numbers. Not always. No, they don't. Because when students get to 8th grade and we're now looking at slope, we don't need to rewrite those improper fractions at all. Okay. The most you can have is 100%. No, because we start to talk about increase, right? When we start to talk about increase, guess what? I now have more than the original, which is going to be more than 100%. Two negatives make a positive. Not always. And unfortunately, students focus on what they feel like is most important. They don't even hear all the other stuff that you said. You said you might have said a whole bunch of other stuff other than two negatives make a positive. But guess what they heard? Two negatives make a positive. Bam. I'm gonna use that every single time I see two negatives. The negative number is bigger, so the answer is negative. Again, we got to talk about absolute value. We have to talk about magnitude. We need to use number lines. We need students to understand and make sense of things versus just giving them a rule. Now, I know that there are some conventions that exist in mathematics, and the book admits to this as well. They're not saying we need to forget the conventions, okay? If there is a convention, that is what it is. But some of these rules are made up, and that we've just been saying them so long that they feel right, but they're not right, okay? Keep, change is the other one that I'm going to mention today, okay? It's the last one I mentioned. For subtracting integers, just use the number line. Keep, change. Use the number line. I promise you, if you need help on using a number line, check out my TikTok because, again, it's Math and Statistics Awareness Month. I did about a 7-day, I won't say challenge, but 7 full days on ways that we can use the number line. Check it out. I promise you, it's so much there for you. These rules come up a lot, and the math pack dives into even more of them. But I want to leave you with this. When we teach rules that expire, students use the rules as they interpret them, not necessarily as you want them to interpret them. They don't think about the rule beyond its immediate use. Even students who seem mathematically strong, they have a hard time letting go of rules they believe work. And once a rule is taught, it's hard to unteach. Now, I know if you are in primary, you might be like, well, it ain't my problem no more. Some of our middle school teachers may feel the same way. It's all of our problems. Because remember, we are a part of the foundation. If the brick that you're bringing to the project has holes in it, if it's cracked, if it's crumbling, you hurting us, okay? You hurting us. I need you to think about what are you bringing to the foundation that we're building for these kids. If it's not a whole brick, I need you to go ahead and take it back. I need you to take it back and lean into your PLC, your professional learning community, lean into some PD, lean into something that would allow you to bring a whole brick. And this is not saying that you need to be perfect, okay? Because not all bricks are perfect. Not all bricks are perfect. However, I need you to not bring a brick that you know is split down the middle. So let's teach with clarity. Let's make room for sense making. Let's commit to long-term understanding, not just short-term answers. I appreciate you guys for hanging out with me. It's about a 20-minute episode today. If this episode made you reflect, which I hope it did, or even squirm a little, that's okay. Growth comes from discomfort. I want you to share this episode with a colleague, and I want you to revisit those earlier episodes as well. And stay tuned for what's coming next, because I got a lot in store for you guys. Until next time, keep growing, keep questioning, and keep making math happen. I'll talk to you soon. P.S. I've got a reflection journal coming your way soon, and it's designed to help you turn these ideas that you've been hearing about on each episode into action. It's free and it's powerful. More details coming soon. And if today's episode sparked something for you, don't keep it to yourself. Share it with a colleague, someone who's ready to make math happen. I want us to grow together, so I'll see you and your colleague next week.